this computer. Yes. Okay, today we have another lecture. This lecture will be entitled the Z transformation. Of course, we are going to talk about the Z transformation, and then we are going to solve some numerical examples to illustrate how we are going to determine the Z transformation for a given function, discrete time function, I mean. Now, definition. The Z transform converts a discrete time domain signal, which is a sequence of real or complex numbers, into what? Into a complex frequency domain representation. Now, as you know, signals may be what? Maybe real signals or maybe complex signals. Real signals, as I think you are familiar with the real signals, say any signal are real signals. For example, modulated signals, speech signal, sound signal, video signal. All of these are what are examples for what? For real signals. Of course, how we are going to get complex signals. For example, when we are going to use the quadrature modulation, okay, quadrature modulation. Here we have two channels or two panels, okay. One of them will multiply the information signal by the cosine t. The other panel will multiply the signal by the sine t, and then it will be combined together and transmitted over the channel. These two signals cannot be combined together in this way. Why? Cosine signal represents the real part and sine signal represents the imaginary part. So in such a way, we have what? We have a complex signal, I mean, real plus j, a value, okay? So a simple example for complex signal is what? Is a quadrature signal. So we may have complex signals to be used in the discrete time system. Second thing, the Z transformation will convert the given signal into what? Into a complex plane, into complex frequency domain. Now, what do we mean by this? Really look at the Laplace transformation. Previously, we have studied the Laplace transformation. And the Laplace transformation, again, we deal with what? With complex plane. I mean, we have real, which was alpha and sigma, okay, and j omega. Sigma and j omega in the Laplace transformation. Of course, there are a great similarity between what? Between the Z transformation and the Laplace transformation. Both of them will convert the signal into what? Into a complex plane. This is the first thing. Second thing you have to keep in your mind again, that's what? Now, the Z transformation will be used for what? To simplify the solution of the difference equation. On the other hand, when we are talking about the Laplace transformation, again, the Laplace transformation is used for what? Is used to simplify the solution of differential equation. Differential equations are used for what? Are used to model the physical phenomena and convert it into what? Into mathematical equations. Now again, the same thing. The difference equations are used what? Are used to model the discrete time systems and convert it into what? Into difference equations. So there is a great similarity between these two transformations, but the Laplace working on what? On analog system, and the Z transformation deals with what? Deals with discrete time system. It can be considered as a discrete equivalent of the what? Of the Laplace transform. Yes. Now, what will be the basic definition of the Z transformation? Now, to convert any signal or the discrete time signal to the Z domain, we are going to follow the basic definition of the Z transformation, or we are going to use the basic formula. Basic formula will be x of z equals to summation n from minus infinity to infinity, x of n, z to minus n. Now, we are going to what? We are going to assume that Z will be what? E to the J omega. So there is a connection between discrete time Fourier transform and the Z transformation again. So x e to the j n minus infinity to infinity x of n to the minus j omega n. Okay, this will be the basic definition of the Z transformation, and we are going to utilize this equation for finding out the Z transformation for a wide range of signals. Of course, the question is why we are going to use the Z transformation, a generalization of Fourier transform. Fourier transform doesn't converge on all sequence. This is the problem we have. For example, when we are going to deal with the Fourier transformation, discrete Fourier transformation, I mean, for discrete time signals, uh, in many cases, due to them using the Fourier transformation, the signal generated by the Fourier transform will not be a converge signal. Of course, now we have a question, what do you mean by converge and diverge signal? Converge signal means the signal we are going to find a plane by which the magnitude or the value of the signal will be less than infinity. On the other hand, we may have some signals, their magnitude will be what? Will be infinity. So these kind of signals are called what? Are called diverse signal, and we are not going to make use of such a signals. So what we are going to do, the solution will be what? So the solution will be to move toward what? Toward the Z transformation to find out a converge output. Notation is good for what? For the analysis, especially for complex signals. Bring the power of complex variable theory, deal with the discrete time signals and systems. Now, let's go to the Z plane to understand what's going on. X of Z will be summation from n minus infinity to infinity, x of n z to minus n. This will be the basic definition, and this definition will be used to determine different signals, really, or wide range of discrete time signals. Now, look, please. When we have talked about complex plane, this will be the complex plane. X-axis will be the real axis, and the y will be the imaginary axis. Now we said that z will be e to the j omega. Now look at, please. Omega will range from 0 to 2 pi. Okay, range of the omega will be 0 to 2 pi. Now we have a vector. Okay, this vector is represented by magnitude 1. Okay, 1 multiplied by the minus j omega. So it will be 1 multiplied by e to the minus j omega. Now e to the minus j omega represents a phasor. Okay, now this phase will change from 0 up to 2 pi. Okay, up to 2 pi. Now we have a vector, its length equal to 1. Its length will be 1, and it will be moves from 0 to 360. Of course, the locus for this vector will be what? Will be a unit circle. So this the locus for the z variable will be what? Will be a unit circle. Well, now up to now we have what? We have talked about the z variable and its locus. Its locus will be what? Will be a unit circle. Good. Okay, evaluated on a unit circle. Now, by now we have some properties. As I think in the field of the Fourier transformation, Laplace transform, you are familiar with these transformations. As I think you have heard about properties and say table of transforms and duality properties and so on. All of these things are available where in the Z transformation. Now, in this lecture, really, we are going to talk about only the basic 3 properties. First one will be the Z transform are linear. Now, what do you mean by linear? Of course, at the end of this lecture, I'm going to show you what do you mean by the linear function. When we are dealing with some complicated functions, now the function may composed of more than one part. And here we have, in this example, we are talking about only two parts. So what we are going to do, of course, dealing with the function together will be what will be a difficult job. So what we are going to do, we are going to partition the signal into parts, okay, or divide it into some parts. Now, in this example, we are talking about only two parts. So ax of n plus by of n. Say these two functions are what are belongs to another function, which is, for example, w or k function, anything else. Well, now, what we are going to do, first of all, I'm going to determine the z transformation for the x of n, and then for the y of n. At the end of the day, I'm going to what? I'm going to combine the result of x of z and b of z together to get what? To get the overall z transformation for the given function. Of course, I have told you that the function may composed of more than one part. Well, so all we are going to do, we are going to combine and determine the Z transformation for the functions individually and combine them together to get the overall result. Now, second important property is what is the shifted sequence. Of course, for example, here we have the Z transformation for what? For x of n plus n naught. Either you have plus n naught or minus n naught, okay? Of course, if you have minus n naught at that time, the signal, we have the Z transformation for the same signal, but it will be multiplied by, say, Z to minus n or Z to plus n based on the what? Based on the amount of shifting. Either it will be shifted to the right or shifted to the left. Another important property will be the multiplication property. Of course, a to power n signal in the discrete time systems is called exponential signal. A to power n is called exponential signal. Now, multiplication by exponential signal will lead to what? Will lead to scaling the z values in the z domain by a, okay? By the multiplication will affect the region of convergence, and all power zero locations will be scaled by a factor of a. Now I have talked about the Z transformation theoretically. Now let's go to solve some examples to illustrate what's going on. Okay, now I'm going to show you some examples at the beginning. Then we are going to talk about important things, which is the region of convergence and other important issues. Starting with example number 1. Okay, now we have example number 1. In example number 1, given x of n equals to the following: 1, 2, 3, 4, 5. Now, of course, when I'm going to put this arrow, this means that at this point we have n equal to 0. Okay, so this represents the beginning of the sequence. Of course, how I am going to, this is given x of n. Find the z transform. Okay, find the z transform for this signal, I mean, of course. Now, how I am going to determine the Z transformation for this signal? I'm going to use the general formula, which is what? Which is x of Z equals to summation n from minus infinity to infinity x of n Z to minus n. This will be what? This will be the general formula for the x of Z. Now I'm going to plot the signal first of all to illustrate what's going on, and then we are going to apply the formula. This will be n, and this is the x of n. Okay. Now, can anyone tell me how we are going to plot the signal, or the signal from minus infinity to 0? What will be the value of the signal from minus infinity to 0? What will be the value of the signal from minus infinity to 0? Huh? Are you with me or you are out of coverage area?
We are with you, but I think it will be 0, but when n equal to 0, it will be 1, according to the given data.
According to the given data, it will be what? Repeat it again, please.
It will be 0, but at n equal to 0, it will be 1.
Yes, it's good. Yes, exactly. You are talking exactly good. Yes, from minus infinity to 0 to 0, okay, here we have 0 values, okay, all the values are 0 except at n equal to 0. At n equal to 0, of course, we have values. So I'm going to plot the values. Okay, this will be 1, and then we have 2, 3, 4, and 5. Okay, now 0, 1, 2, 3, and 4. Okay, so this will be the graph of the function x of n. Now, as you can see, it's very clear that the signal from 0 up to n will be what? Will up to n equal to 0 will be 0. So the summation limits will be changed. Okay, now the summation limits will be changed and it becomes x of z equals to summation n from 0 up to infinity x of n z to minus n. Okay, now the function starts from n equal to 0, so the limits of the summation will be changed from minus infinity to infinity to 0 to infinity. Okay, of course, again, we can note another important point, that the signal ends at n equal to 4. Of course, after n equal to 4, again, the signal value will be what? Will be zeros. So the summation limit will be n from 0 up to 4, x of n z to minus n. So in this way, the summation is simplified. Well, now what we are going to do in the next step, we are going to expand the summation and substitute the values. Well, so x of z, look, x of z will be x of 0, z to minus 0, plus x of 1, z to minus 1, plus x of 2, z to minus 2, plus x of 3, z to minus 3, plus x of 4, z to minus 4. Well, this will be the x of z for the signal. Now the remaining will be what? To substitute the values of x0, 1, 2, 3, 4. Okay. Now x of 0 will be 1. Z to minus 0 will be again 1. So it will be 1 plus x of 1 will be 2, z to minus 1, plus 3, z to minus 2, plus 4, z to minus 3, plus 5, z to minus 4. That's all. Okay, now we have determined what? The x of z for this function. Now, can anyone tell me which values of z will make x of z infinity? Okay, again, I'm going to repeat the question. Which values of z will make x of z infinity? Can anyone tell me the answer? I'm waiting for your response.
Infinity معناه
Huh?
Infinity.
Infinity؟
بله.
دي بجربين infinity. Infinity يا قيمتك هذه. Okay, now you said it's infinity. ترى في تشي برا؟
Muhammad
Okay. Muhammad said the value is infinity. Muhammad said the value is infinity. Okay, now I need other opinions. Okay, other values. What will be the other values? Huh? بله خوب then. okay, I'm going to rewrite the x of z in another way. Look, x of z will be 1 plus 2 over z طبعا plus 3 over z squared plus 4 over z cube plus 5 over z to power 4. Nuka, which
Zero يا
value?
نوكا.
Zero.
Zero.
0 عفوا. Okay, 0. Yes, 0 will make what? Will make the value of x of z to be infinity. Okay, and this time the 0 will make what? X of z infinity. So, as I have told you before, our main objective is what? To find out x of z functions that will be converge function. So if we are going to substitute z equal to 0, this will lead to what? This will lead to the value of x of z becomes what? Becomes infinity. X of infinity means, sorry, value infinity, it means that the signal becomes what? Or the function becomes diverge function. So we have to what? We have to avoid values which makes x of z infinity. Okay, so ROC, okay, region of convergence, for this signal will be what? All, I'm sorry, entire z plane on all values of the z plane, entire z plane. Entire z plane means what? Means all values of the z plane. Okay, entire z plane except z equal to what? Equal to 0. Okay, so all values of the z plane can be used except what? Except z equal to 0. Why? Because z equal to 0 will make x of z equals to infinity. By now, as I think, we have what? We have introduced a new term, okay, which is what? Region of convergence. Okay, region of convergence, a plane in which what? In which the values of x of z will be what? Will be not equal to infinity. Okay, will be converge. Well, this is the definition of the ROC for this function. Of course, this function, look please at the graph of this function. This function is called what? Is called right-sided function. Okay, right-sided function. Why? It starts from 0 toward what? Toward the right-hand side sequence. Well, we have another example, example number 2. Now, in example number 2, we are going to deal with another sequence, ex2, given x of n equals to, look please, 4, 3, 2, 1. Okay, this will be at n equal to 0. What does it mean? It means that 2 will be what? At n equal to -1, and 3 will be at n equal to -2, and 4 will be at n equal to -3. Okay, this is the explanation of this notation. Okay, whenever I'm going to put an arrow at a point, it means that this point or this sample represents the sample value at n equal to 0. Well, now let's go to the solution of this example. Of course, again, I'm going to use the general formula of the x of z will be summation from n equal to -infinity to infinity, x of n z to -n. Now, it's very easy to conclude that the limit of the summation will be changed and become, look, summation from n equal to -3, okay, n equal to -3 up to what? Up to n equal to 0, okay, x of n z to -n. This will be what? This will be the summation of this signal. Now, let us substitute, of course, starting by x of -3, okay, z to what? Minus 3, plus x of -2, z to -2, plus x of -1, z to -1, plus x of 0, z to -0. Now, next step is what? Just I'm going to substitute the values. Now it will be 4z cube plus 3z squared plus 2z plus 1. This will be the x of z for this sequence. Of course, if I am going to plot this sequence, okay, easily we can plot this sequence. Okay. Well, now easily we can plot this sequence. Again, this will be n, and this is the x of n. Look, please, at n equal to 0, the value is 1. Okay, at n equal to -1, n equal to -2, and n equal to -3. We have values which are this one will be 2, this one will be 3, and finally we have 4. As you can see, this sequence will be a left-handed sequence. Okay, starts from -3 and ends with 0. Of course, after 0, the values will be 0. Now, can anyone tell me which values makes x of z infinity? Now you are given x of z. As you can see, x of z is given. Okay. Now you need what? You are going to what? You are going to determine the values by which x of z becomes infinity. Now, can anyone tell me which values makes x of z infinity or not?
Doctor, now it is infinity.
Now it's infinity. How? Which value of z makes x of z infinity? Z equal to what? Huh? Which values of z makes x of z infinity? Yani z equal to what?
Infinity.
Infinity. Okay. So if z equal to infinity, x of z becomes infinity. So in this way, now here I'm going to determine ROC. Now ROC will be what? Will be entire z plane, all values of z plane, I mean, except what? Except z equals to infinity. So we have to avoid the value of z equal to infinity. Why? This will make x of z equal to infinity. Now, the third example in the first hour, of course, will be example 3. Here we have example 3. Now, in this example, we have the following signal. Look, please. Given x of n equals to 3, 2, 1, 2, 3. Okay, and this will be the center of the signal. I mean n equal to 0. As you can see, this is an even signal. Now let us at the beginning make a simple plot for the signal, and then we are going to determine the Z transformation and the ROC for the given function. now this will be
دكتور بس سؤال.
بلى عزيزي تفضل.
بس دكتور يعني احنا دائما نبدا من الواحد.
لا مو شرط، لا مو شرط، عادي اخلي الارقام بالبساطه ما ايش اسمه، مو شرط. بس من نخلي
يعني
الان صفر، من الان صفر دحق الان صفر، هاي شنو؟ هاي يعني منطقه الصفر مالته يعني ماكو، مو شرط.
تمام.
اي بس بدي احدد لك المنطقه مالت الزيرو مالت السيجنال.
يعني دكتور يعني انت بالامتحان تحددني لو لازم احنا نعرفه؟
لا هاي احد لك اياها. شوف ايش التحديد. خوش سؤال بس دقيقه واحده خليك معي. شوف اذا اعطيتك السيجنال، اذا اعطيتك السؤال مثلا بهذا الشكل، مثلا قلت لك x of n equals 2 فتحت قوس او خليت له ارقام، اوكي مثلا هذه اذا ما حددت لك ال n يساوي صفر وين راسا تفترض اول قيمه هي ايش عند ال n equal to 0.
تمام.
اوكي. اما اذا حددت فراح يكون واضح يعني مثل ما عندي احدد حاليا. اوكي بالامتحان ما راح احدد لك يعني وين ايش اسمه. otherwise اذا ما حددت فمعناته تعتبر اول عنصر بدينا به هو ايش؟ هو القيمه عند الصفر.
شكرا دكتور.
نعم عزيزي يا مرحبا. اوكي. Now let us at the beginning make a simple plot for this signal, and then I'm going to find out the z transformation for x of z. Well, now this will be n and this will be x of n. As you can see, at n equal to 0, n0, n equal to 1, and n equal to 2, you have values. Here we have at n minus 1 and at n minus 2, at n minus 2. This will be 1, and then we have 2, and here we have 3. Okay. Otherwise, it will be 0. Now, after plotting the signal, now we will be able to determine what? Determine the Z transformation, of course, after using the general formula, which is the summation from minus infinity to infinity, x of n, z to minus n. Please write down your names in the chat for the attendance, okay? Write down your names in the chat for the attendance of the first hour. Well, now here we have the following. Now, due to the signal starts from -2 and ends at 2, the limits of the summation will be changed from -2 to 2, x of n z to minus n. Now I'm going to expand the summation, and it will be as follows. X of -2 z to minus 2 plus x of -1 z to minus 1 plus x of 0 z to minus 0 plus x of 1 z to minus 1 plus x of 2 z to minus 2. Okay, now we have we are going to substitute only the values, so it will be 2z squared plus sorry 3. It's a 3, yes, it's a 3. I'm sorry, it will be 3z squared minus 2z plus 1 plus 2z plus 3z to minus 2. Okay, now this will be the x of z for this function. Okay, this will be the x of z for this function. Now, my question is, which values of z will make x of z infinity? Which values of z makes x of z infinity? Can anyone tell me?
0 at infinity.
عفرم دست خوش. ترابيتشيا
مسعود.
مسعود دسخش مسعود. Yes.
Mr. Saida.
Now the ROC for this function, ROC for this function will be what? Will be entire Z plane, except Z equal to 0 and Z equal to infinity. Okay, of course, by this example, we have finished the first hour. Now, take your rest, and we are going to continue at 1 o'clock, inshallah. Thank you, and see you at 1 o'clock.